If you are using the predefined network profile, depending on the number of uplinks or the number of ports available in your network cards, we will configure NIC teaming and failover policies like this. So we typically use active standby. You have the possibility to switch to active if you want to, but default configuration is active. And if you ask me, it works best for most of the environment. The advice I always give customers, if you want to make some change, if you want to go active, try that in a dev and testing environment. See if it's going to really add some enhancements and benefits in terms of performance to your environment. Measure the impact using different measurement interfaces available in your VxRail environment. And if it gives you some significant improvement, you can implement that in your production environment. If you don't see any improvement, it's not worth the effort, because some configurations will require really high complexity in terms of network configuration. For example, if you want to go with link aggregation and have that implemented for your vSAN traffic, so in case of an issue, you may get a lot of troubles when troubleshooting the issue. So it's not really worth the effort, especially if you don't see any improvement in terms of performance from a production point of view. Anyway, for us, we go active standby. This means that the traffic is always up from one link until that link is down. And then we will move to the second link. If you have two ports, okay, if you have nodes with two ports, these two ports can be 210 gig or 225 gig. We're going to use active standby. If you look closely, you can see that one port is fully dedicated to vSAN. So vSAN traffic is a very demanding traffic. This is your storage traffic. This is the read and writes from where reads and writes are coming to your VMs. So we will dedicate one port for vSAN. Until that port is down, then vSAN will use uplink 1 and it's going to share the traffic with the remaining traffics. Okay? If you think that this may cause some decrease in performance of vSAN, if there is a failure, do not forget that you are using VDS here. So you have the possibility to configure optionally network I/O control, which is not part of the deployment. It's up to you as an admin to configure that, to set some hard limitation, or you can guarantee. This is basically going to let you guarantee the availability of certain bandwidth in case of a failure that may affect vSAN as a traffic. Okay. Second option is when you have 4 ports. It's a network card, an integrated network card with 4 ports. Here we have more flexibility. So we're going to use active standby again, but the distribution will actually take in consideration all the available ports. So for example, vSAN in this case will be active on uplink 3 and standby on uplink 4. vMotion is going to be active on uplink 4 and standby and active on port 3. The only port which is using 2 active traffics is uplink 2, and these 2 traffics are the management traffic, which are less busy and they don't really consume a lot of bandwidth. If you have an integrated card with a PCI Express card, the idea is to build failover pairs or NIC teams using one port from the integrated card and one port from the additional card. So for instance, here we have an integrated card with 2 uplinks and then PCI Express card with 2 uplinks. For instance, 225 gig plus 225 gig. So each traffic will be active from the PCI Express card, for example, and standby using one internal port. Or it can be active on one internal port and standby on one external port or one PCI Express port. Any questions about this part? No questions? Okay, I hope that everything is clear. So for policies, by default for each VDS, this is what's going to be used if you go with the predefined network profile. As a reminder, the predefined network profile is going to use the default configuration. So for load balancing, we use the route based on originating virtual port. This policy will send the traffic to the same physical uplink until that uplink is not available. This is a policy that consumes the smallest amount of resources in your vSphere environment for hashing and calculation in terms of network resource usage. So that's what we use. It doesn't try to load balance. It doesn't try to monitor the bandwidth or whatsoever. Really sends the traffic to port 1. If port 1 goes down, let's send the traffic to port 2. Then we set the network failure detection to link status only. Okay, so this is capable of detecting only the failures which are affecting physical ports. Okay, when there is a failure at one physical port level, the network failure detection will detect it. This means that beacon probing is actually not supported, right? If you have a failure that prevents the nodes from talking to each other, which is caused by something outside or something that goes beyond the Tor switches, maybe VLAN misconfiguration on the core switches or something like that, this cannot be detected. Okay, beacon probing is the second option. It's not supported in VxRail anyway. Notify switch is set to yes if we have a failure. Okay, so this is a node. It's got two ports, right? And we have the two Tor switches. Okay, one port here, one port here. We uplink like this, active standby. So if we have a failure here, the notify switch will let the VDS or the virtual distributed switch tell the Tor switches, hey, I'm not going to uplink using this port anymore. The MAC address must be changed on your end. I'm going to start uplinking using this MAC address. Failback is set to yes. This means that if you got this port fixed, we'll switch back to the initial configuration. Without this option set to yes, second port will continue to act as active, and the other one must be manually configured to become a standby port. This is not ideal to keep consistent configuration, similar to day one when the cluster was deployed. So typically or basically we set this to yes, so you can have the configuration as it was configured in the beginning once we got everything fixed. So these are default settings from a network point of view. When you deploy your cluster, here you can see some considerations. So first of all, if you have a single network card, the integrated one, that's a single point of failure. Okay. Adding an additional card will come with a cost, but will guarantee a continuity of the business if there is a failure on the network card. You don't need to worry too much about that. I can tell you that the failure rate of network cards is extremely low to non-existent. Each port group is configured with one active and standby uplink. So load balancing is not configured. There is one VDS for all your traffics. What can you do post-deployment? Well, you can add a PCI Express card to all your nodes. This can be planned later. If you don't want to invest from day one, you can add later some additional PCI Express cards. For example, you have an integrated card of 2 ports, you add some additional 2 ports. Uh, the integrated cards must be the same on all nodes. The PCI Express cards, however, can be of different speeds. Okay, we do support mixing cards from different vendors, supported but not recommended. So day 2, you can enable redundancy of card by adding a PCI Express card. You can enable load balancing. More specifically, you can enable link aggregation for types of traffics like vSAN, vMotion, and your production traffic. It's not supported for management because it doesn't make any sense to enable link aggregation for management. No one does that. And you can deploy a second VDS for many reasons: security, performance enhancement, etc. Okay, so here is an example of how we can move from an initial configuration of 4 10 gigabit ports to a configuration where we have 4 10 gigabit ports and we added 2 10 gigabit PCI Express cards. So in this case, since the initial configuration was 4 ports, we're going to have 2 ports left not actually being used. They can be used for many things. Like, for instance, you can mount your vSAN cluster or vSAN data stores in this SCSI target. You can use them for replication or many other use cases. This is just simple example. Here you can see a table of starting configuration and ending configuration. There are plenty of possible combinations. Have a look at the specification sheet of each one of the nodes. And by the way, normally you should all have received your student guides. Once you are registered in our learning management system, by default, you get a notification to download your student guides. The student guides are PDF files tagged with your own email address for security reasons, so they cannot leak on the internet, for example. And the student guide is actually the presentation I'm using with all the links and stuff you need for reviewing the content later. So make sure to download them. It's not actually on the same platform on which you were registered. It's a platform called Content Raven. You get a separated email called ebooks for your upcoming class. And in that ebook, you get all sorts of, for example, app links. For instance, here you have some explanation. Sometimes you have URL, the link to a URL to download documents. So you can use your PDF to download all sorts of documents. I'm going to make sure to share many of them with you before the end of the class. So this is the first change you can make to your network configuration. Next one, you can enable link teaming with link aggregation for load balancing and improvement in the performance. That doesn't guarantee performance in terms of network resource usage. So it's up to you as an admin. As I said before, this will require measurement, having a discussion with the network team. Link aggregation will require configuring link aggregation protocols on your Tor switches like LACP or static link aggregation. You're going to need to have a multi-chassis link, need to connect the switches together, and you're going to need to dedicate 2 ports for all sort of traffic or traffics with link aggregation. For example, here we have Uplink 3 and Uplink 2, since we're using the integrated card and PCI Express card with LACP. So using Uplink 3 and Uplink 2, we're going to have vSAN, vMotion, and production traffic. Uplink 1 and Uplink 4 will be dedicated to management, internal management, discovery, and external management. Okay. Reason for this is obviously the traffics that can take most of the benefits of link aggregation, if there are any, are the most demanding traffics. First one that comes here is vSAN, the most demanding traffic, then vMotion, which is a bursty type of traffic, and then your production traffic. Okay. And you can deploy a second VDS. There are plenty of reasons why you would need to do that. Improve the performance, security reasons. If you have physically separated networks, you may need to have physically separated virtual networks for ease of management. So for example, here we have two VDSs. So two VDSs can be either deployed from day one using a custom profile with two VDSs, or can be done later by simply adding a new VDS. There will be a lab coming up next on day 3 where you guys are going to deploy a second VDS. In this particular example, in our first VDS, we have a production traffic and VxRail management, all sorts of management. In our second VDS, we have our second production traffic and vSAN and vMotion. One thing you can note here is the number of uplinks, which is really huge, because once a network card is dedicated to one VDS, it cannot be shared with another VDS. Hence the requirement of more than one physical network card. And here, for instance, we're using 3 PCI Express cards in addition to the integrated one. So it's a heavy investment, but may be required for some use cases. Okay, so here is another question. Normally the knowledge check is to basically see how much you guys can remember from each module. But since I'm using the online version of this content, the questions are already answered, unfortunately. So this one is asking you that an admin sees some latency and he wants to improve the performance of a VxRail cluster. So the cluster is deployed using a predefined network profile. And what can the admin do? The correct answers are you can deploy a second VDS for vSAN traffic and enable NIC teaming with link aggregation. These are two actions that can help improve the performance and reduce the latency.